Okay, so I would like to introduce him to you. Lippu is currently the founder and chairman of Walden International, a leading venture capital firm that manages over 2 billion US dollars. On top of that, he also serves as the president and chief executive officer at the Cadence Design Systems, and actually he has been on the member of the Cadence Board of Directors since 2004. Lippu has received a number of degrees from some top flight institutions, including a Bachelor of Science from Nanyang University in Singapore, a Master's in Nuclear Engineering from MIT, and an MBA degree from University of San Francisco. On top of his two very important jobs, Lippu actually also serves on the boards of several top-notch institutions. That includes our own institution, Carnegie Mellon University. Actually, he is both on the board of trustees at CMU, and as well as he is also serving on the CIT Dean's Council. He holds similar positions at MIT and Berkeley. And last but not least, he serves on the board of directors of Global Semiconductor Alliance. Without any further delay, I would like to leave this stage to Lip-Bu Tan, who is going to talk about semiconductors, which, in his words, are the engine to drive the technology innovation. Let's welcome. Yeah, your mic is on. Okay.
Yeah,
That's
okay,
right.
sound good. So in that case, I can just use this one, maybe.
That's also
Okay, good. Well, first of all, thank you for coming for this talk, and then try to make it as interactive as possible. Feel free to interrupt me anytime. I have two jobs, so I'm kind of presenting a combined presentations, and so I always tell people that cadence design is my real job, and then investment is my hobby. And so my hobby is 2 billion investing. So that's how I work. Um, Today, what I'd like to do is to get you excited about the importance of the semiconductor and impact into the whole big industry. I'm going to start with playing a video for you. It's a live as a semiconductor. I hope it works. So this video give you a flavor of semiconductor, pretty much involved with your daily living. And this is put together by the GSA, Global Semiconductor Association that I'm on the board. Kind of highlight some of the application of the semiconductor. What I'd like to do is also GSA just published a new economic impact of semiconductor. They have a lot of detail. I think you can get a copy of it if you go to the GSA website. There's about impact into about $7 trillion industry, and that's an impact. A lot of time the semiconductor is embedded inside the system that you may not see it, but it's really driving a lot of application, a lot of all the killer app that we all enjoy doing. Let me talk a little bit about the opportunity, why I get so excited about semiconductor with my 2 feet and 2 hands in semiconductor. Couple of big drivers. I just want to highlight to you. I think we all know the mobility. I carry about 4 different devices, and so it's no more just phone. It's almost every information you need you can access. It's almost like supercomputer 20 years ago. And in terms of how much information you can get and how much information can push to you. And clearly, mobility is a very big area. And then the cloud data, I mean, a lot of things all stored in the cloud, and a lot of massive infrastructure are building up, and a lot of challenges facing, and then I will talk a little bit later on. And then Internet of Things, people talking about 50 trillion, 50 billion devices. And then John Chambers at Cisco talking about 14.4 trillion impact into the industry in terms of profits. And so a lot of connected device going to be happening, and it's already happened. And so a lot of machine-to-machine talking, and then people think that you wear, and some of them that even implant into under your skin, so that a lot of things is happening, and it's really exciting. And machine to machine, it has to be very low power, and it's always on. And application impact can be very wide. Some of them is just a little bit difficult to imagine. I hate to have my washing machine talking to my dishwasher, and so I'm not know what they're going to tell each other. So, but anyway, this is the trend that we are going forward. 10, 20 years from now, there's a lot of things that you may not even imagine, and we will be using it. It's going to be exciting. And then the couple of big trends I mentioned earlier, if you look at these 3, are very big platform in terms of 141 billion for the mobility. Cloud, 21 billion, it's growing very fast. And then Internet of Things is growing very rapidly. And there's a lot of more detail we can talk about later on in terms of the new emerging area opportunity. Then we look at some of the end market, and then clearly, some of this vertical market, you can see how big a platform can be. And then lately, I've been investing quite a lot in the medical side. Later on, I will touch on a little bit for you. And that's all related to healthcare, and then the measurement. In fact, the most exciting right now I'm involved actually is a spin-off from Berkeley. and basically able to provide single cell drug discovery. So all the cancer, tumor, using, most of the time right now using is manually. It's very error prone and it's very unable to be very predictable and repeatable. And lately, there's a new company development using the optofluidic technology, and a couple of patent files, is very powerful patent. A lot of big pharma are using it for identify the more, they call it rare antibodies, and then so that they can do much better and more accurate research. And even in the baby, in the test tube, they can be more predictable and a much more nicer way to handling it. And so those are the things that is excite me a lot. And then automotive, there's a lot of application in automotive, not just for infotainment, and then the connectivity, and also the collision avoidance, and then also the machine to car in terms of the communication in the range of 77, 79 gigahertz. So very exciting new development are happening right now. Then we can extend that into the smartphone, smart home. This is a big area, and Google is heavily investing in it. They bought Nest, and then now they bought Dropcam, and then a lot more going on. And with Tony, he's working on that. So I think all in all, smartphone and become a very important, rather than a lot of devices you have to do the remote control. Lately, I invest in one company that's doing the gesture. So all, just wear a ring, and then you can point to 16 different devices. You can control your lighting. You can control your TV. You can control your presentation, your temperature, the Nest. And with just one finger, you can just do gesture controlling it. And rather than you have to step up and then go and switch on and off, or multiple device, remote device. My kid play a lot of game console, and I don't even know which one that he's using. So, and then it can be very complicated in the future. It's going to be all gesture based, and voice based. So I think it's going to be very exciting. And then the other part is smart city. There's a lot of program going on, and in some way, when I traveling to Korea, traveling to China, when I come home, I said, well, US and we are very behind. And that in terms of the speed of the connectivity, in terms of all this smart, intelligent environment. And sometimes because being a new, they can leapfrog just like mobile. They don't need to have a fixed line. And so much more progressive in terms of technology adoptions. But anyway, this smart city, if you talk to IBM, they are going big time into some of the smart city initiative and effort. The other big trend happening is, we're all familiar with I call it the I-10, the Google, the Amazon, the Alibaba, Tencent of the world. They all providing a lot of application and services like e-commerce, search that we all enjoy doing it. And then now they decided to optimize all the way from the silicon level. And so a couple of them already have the aggressively hiring silicon team. So this is a very big change in the past that usually software and service and the hardware guy were all separate, now are intertwined. And so some of this a big guy and become very important semiconductor player. And in fact, it will be shocking to you because I'm on the hidden design. So all the advanced design, most of them using my software tool and IP, you'll be shocked to find out that 40% of my revenue today are the system company, not the silicon guy. And it's shocking, 6 years ago when I took over turnaround Cadence, and it's only 5%. And so you can see this trend has happened very rapidly. And so they try to optimize in every layer, from the component all the way to the software stack, and so that they can really optimize the massive parallelism, the power, the optimization. And so this is a sea change happening going on. And then the couple of big system company like Lenovo, they're all setting up the semiconductor team, and Microsoft is also doing that. So I think this is exciting big trend happening as we speak. And the other big trend is China. And if you look at this chart, right now they consume 50% of all the semiconductor component in the world. And their government is very, very proactive. They view semiconductor as strategic to them. And they're very smart. They realize that's how important, more than oil. And so they're starting to pay attention to it. And in fact, my next slide going to show you, they set aside almost 45 billion investing into the semiconductor design and manufacturing and packaging. So in a way, it becomes very strategic for them. And then they acquire a couple of companies, and like for example, Spectrum, RDA, Montage, Omi Vision, Image Sensing company was acquired, now in the process of being acquired by the Chinese company. And so there's a very big push about the semiconductor development. It's very foundation component that they need to have. And in fact, I always joking with a couple of my friends running Google and Facebook and Alibaba. All these killer apps that you guys are providing, without the silicon, you can't drive it. My cell phone, I don't know about you guys, about 11 o'clock in the morning, they run out of battery. Because there's so many killer apps that I have, and they are very power hungry, especially in anything related to video, anything on search, or you do traffic, you waste. And then if you don't shut it down, you thought that you shut it down, it burn a lot of power. And so there's a lot of innovation needed in this area to drive. And then they're starting to realize that. And they're starting to say, okay, Lip-Bu, you're right. We're starting to invest and then build the component optimized for our services. There's a lot of challenges. I want to highlight some of these challenges. It basically encourage you, there's a lot of innovation needed. And it's not the end, there's a lot of more things coming. So, everybody heard of Moore's Law, and then if you study WE, and clearly Moore's Law is pushing, to, and challenge and more challenging. And when you move down, right now we are doing a lot of volume in 28 nanometer. Now we're heavily involved in the 14 and 16 nanometer, and then already start on 10 nanometer and 7. And then the double patterning, triple patterning, the lithography become a limit. And then that's why I think some of you heard about EUV, and that's where a lot of investment are doing that to drive some of this. So being a good engineers, I mean, all of you are, we always find way how to design around it. And so that's why you're double patterning, triple patterning, color, and all the technique try to move around and, the wall. And then eventually, hopefully, you can break the wall, then it will continue to grow. So this is exciting, and there's a lot of innovation needed. And so we're heavily involved with that. And the other part is, some of you may have heard of system on chip. SoC is very integrating some of the system level thing into the silicon. And there's a lot of IP block, as big as 123 different IP block. You have to integrate together, a little bit like Legos, how to put that together. But you have a lot of challenges more than the Lego. You have power, signal integrity, area challenges, and then all have to come and work together. And there's a lot of challenges to put it together. So a lot of innovation needed. There's a lot of protocol. Almost every different IP, they have multiple protocol, and then you have to support that, and then familiar with that. It's it depends on what application you're trying to drive. The other big part is really, if you look at all the silicon design, right now the most challenging actually is verification and software. And then almost the best company like Qualcomm, MediaTek, and if you talk to them, they are hired 3 to 1 in terms of software engineer and hardware. So you need to really have both to drive some of this SoC. And so, clearly software become a bottleneck. And then how can you drive the silicon while the silicon not ready yet, not tape out yet, and you can start developing your software? That become a holy grail. And then anything that you can move faster, time to market, then you win the marketplace, and you get the market share, and you enjoy the gross margin. Latecomer, you have to do two or three spin, not much money you can make. And so that's everybody is trying to race who can come out faster, the better performance, and then lower power. in a smaller area. And we call it PPA, become very important for all the key design. And so I think, you can see the curve when you move down the geometry down, the cost of designing and the time to market become more and more critical. And so that's why a lot of time we talk about hardware, software, co-design, co-verification, and it become very, very important. If you talk to some of those I-10, even though they have a lot of software talent, but really need a combination of both hardware and software to design and collaborate together. You cannot just throw to the wall, okay, my hardware done, it's your turn to do the software. No, actually you have to, include the software in day one to work together. So it's very, very complex to address that. The other complexity is, just give you example like home smartphone, home electronics. Not only a lot of IP, a lot of protocol. Just give you one example. Like for example, the wireless. And then the different application, the different wireless. The standard and protocol. And, can be Zigbee, can be 802 AC for Wi-Fi. And then so it really depends on Bluetooth. If it's short distance for wearable. And then there's a lot of software, not just the OS, not just the application software killer app. And so there's a lot of software firmware you need to address. And there's a lot of complexity of the design. So right now, people almost impossible to do spreadsheet or calculator to do circuit design. And that's why you need Cadence tool to drive the automations. And then, but not just design, because it's so complex that verification become bottleneck. So there's a lot of verification from functional verification and now to the IP verification and then to all the hardware emulation to make sure that all the design, the bugs you can find out earlier, then you can go to market faster. And also packaging become a problem. And so when you design, wait until you finish the design, then you say, oh my God, your board power is too high. And based on the requirement for the data center or any handset device, and then you go back and redesign, it's costly, and then also you miss the market. So in some way, a lot of people right now are, when they design the chip, they're starting to look at the analysis, how the envelope look like at the end from the board, from the system point of view. Can you still able to do that and meet the requirement so that you don't have to do another 2, 3 respin, but those are costly. When you move out the geometry, to 14 and 10, mass cost can be a few $1 million. And so it's expensive. You try to avoid that. And then the other thing I mentioned earlier is the power and performance. Power become more and more critical in some of the design. So like, for example, in a massive data center like what Amazon is building and Google is building, Apple is growing, they're all very close to the reservoir because you need cooling. The power becomes so high. So anything that you can improve the power of the silicon by 10%, 15% is huge saving. And some of you may not know, the big data center right now consume 2 to 3% of our national power consumption. Is getting more and more bigger. And because of all of us, we enjoy the picture, enjoy the video, and then those traffic are consume a lot of power. And so I think power become very critical. And then some of the function safety become very important if it's automotive. There's a couple of different standards that you have to meet. And so it may make the complication, the design, a lot more complex. And then the other thing I just want to highlight is business is not as usual. Usually, old days, you design a circuit, then you throw to the wall, the software guy will develop something. Now it's become, have the co-design, co-verify together. And then there's a lot of protocol, a lot of standard to meet the requirement. And so there's a lot of more challenges going forward. And then the other part is vertical integration is easy to say. When you really do it, it's very complex. And then time to market is very critical. Some of those great companies that you enjoy, the phone or the tablets or anything that you enjoy those gadgets, the schedule is very tight. If you work with them, one thing that they cannot compromise is schedule delay. And that is very critical. And that makes the complexity a lot more. Just show you kind of alarming for me. That's why I'm so involved with semiconductor. I'm on the VC. Every year we invest about the industry 30 to 40 billion. Can you imagine the semiconductor investment last 2 years, 0.8, 0.9%? That means that VC are no more investing in the semiconductor. And then the other part is if want to do innovation in the big company, it's really hard. And if you join any big company, they can do very well incremental improvement. Disruptive improvement is very hard because how to incentivize the team to take extra risk. Because in the big company, you don't want to get fired when you have some new idea that didn't work. And so tend to be very conservative. The manager also become very conservative. So doing incremental improvement is okay, but disruptive innovation are very hard. And that's why you see some big company like Oracle and even like Cadence, we do a lot of acquisition because doing innovation inside is very hard. And but just look at this chart is very alarming. And that means that people are not investing in the new technology. And then if we don't invest in the new technology, all this killer app that we all enjoy, certain point in time, we got to stop. And that's bad for Google, Amazon, Alibaba of the world. They're starting to realize that this becomes very important. And so how to reverse that trend, I'm happy to chat with you later on. So going forward, I think clearly we are going into a new world, new challenges, need new thinking, a new approach. And that's why you become very important. Because if all the best brain, best talent don't come to the silicon design, we're all going to suffer together. And so, I've been very emphasizing on terms of education and then how to attract the best talent to come to the industry. And we're reaching out to the professor because sometimes professor is very influential for your decision in terms of career. And then some of the best professor I talked to, they said, well, semiconductor is a sunset industry, and they should go to Google and Facebook, and I'm very worried about that. That's why I'm reaching out to some of the professor guy. This is very important. If we don't do some innovation and then change the world, we're all going to suffer together. And so this is a new era, and it's very important that we all, address the issue of some of the challenges we face. So we talk a little bit more about the Moore's law. We talk about new material need to be innovating, not just the CMOS, and then how about multiple new material that we need to look at, and then the lithography, become very important. What are the new innovation we need to make? Power, I talk a lot, how to do. We call it the near threshold voltage. That when you do 0.3 and below, so that you can really do always on for few years or few months. I used to wear Fitbit. Every 3 days I need to charge, and it's not going to cut it. You really need to last for 1 month or 2 months, so that at least you don't have to charge every day. Ideally, it's like your watch, just keep moving. It will run by itself. This should be the way, absorb the ambience, for the power, and that's something. Hopefully, there's a lot of innovation need to be done. This chart is kind of my vision on the Cadence design. So basically, besides providing the tool for people to design chip and the IP block for people build the SoC, and also look at the board level, we have a couple of tools that are able to address the packaging design. And then the next thing, the holy grail, is a system integration, hardware, software, co-design, co-verification, system level analysis, and I mentioned about the power, signal integrity, and then how to analyze before you really build the chip. So those are the things that are going to be very exciting. Then you're starting to move up into some of the vertical, because each vertical requires different area of innovation. And later on, I'll touch on medical, I touch on some of the automotive, and then some of the mobile that, like the power become very critical. Image sensor become very important almost everywhere. And so there's a lot of development in the sensor and the wireless connectivity, and in different universities are working on it. And so that's a very exciting new area of development. And then the other thing is, a lot of things is SoC are all mixed signal. So not just analog, digital, you need to optimize in both. And, and then everybody thought that, everything had to go to digital. but not quite. And now there's a lot of room to grow in the analog side. And some of them cannot replace by digital. And then even some of the analog, the like TI analog device, and now facing some big issue in terms of power. When you move on the geometry, you know that the complexity, power become a real issue. And then a lot of people try to do, digital compensation scheme in multiple way, but there's no one elegant way. We all know that just like Moore's law, you're going to hit the wall pretty soon. And then how going to address and leapfrogging it? And they need a lot of innovation. And so I think, all in all, I think in terms of the high speed, the power related area, and then the mixed signal interference. So there's a lot of challenges facing the industry, but need more innovation. And university can play some part, and then big company have to play some part. And then hopefully I can get VC friend of mine to get excited. And I used to have 30 people I can call to co-invest and syndicate deal. Now, almost none. And then I had to reach out to corporations like Samsung, ARM, and others to team up with me. And so that is kind of sad. And if you don't do it, certain point in time, we're going to hit the wall. And then every other killer app can't provide that. And the speed and performance and power are going to be a big issue. And then the other part is happening is a lot more and more collaborations, and not just the IP player like ARM, not just EDA player like Cadence, the software, the people like Google, Facebook, and all those guys, plus the foundry, the TSMC, Samsung, Intel of the world, and then OEM, ODM player, it become very interested in collaborating together. So like the Flextronic, the Foxconn become very important because they're starting to realize that become the bottleneck for them. So how are we all work together in a very trusted environment? That is the art. And not everybody can do that. And we try to do as best we can to provide that kind of time to market pressure to get it done quicker and then get the chip done faster. And then so that all the killer app software can develop on top of it. And I mentioned earlier, the market and environment has changed a lot. And it used to be, when you design, you throw it to Flextronic, they will do the manufacturing to the end customer. Now no more. That loop become more a circle. And we have to work closely with the end customer and products. And because, then we can fit back to the ODM guy. These are the issues that you're going to face when you do the massive scaling of manufacturing. So those become, the whole relationship change a lot. And then over the next 5 to 10 years. Well, I think I mentioned earlier, I love semiconductor. I invest a lot. And then the last 30 years, actually, while everybody going away and now being a contrarian, and actually I've become no competition at all. I can really enjoy this space, and I wish to have more people to join me on that. And so this is a very busy chart. Now I've been investing a lot globally, and just tell you how fun it is. And how many of you do skiing or bicycling or mountain biking have a GoPro on your helmet? And you like it, right? And that's one of my investments. So it's so fun, to have that. And then, by the way, the Hero 4, you have a 4K video coming up, and it's fabulous. And then you can really enjoy it. And then you look at the inside. If you open it up, inside is an umbrella chip that I also invest, doing the video compressions. And then if you close look at it, you have Aptina imaging, and I also invest in that in the imaging side, I think the other side. And then, so it's kind of fun to see that your silicon you invest in, and then you end up that you enable some of the end product, try some cool killer app, like GoPro, you can take all the video, you can share with the family. My 2 boys and my wife, we all four, when we do skiing, because we all separate out because of the level of skiing. My 2 boys just love skiing in the back mountain, that uncharted area. And we only at the end of the day we see them, but at home we can see what are the area that they go to. By the way, they both are educated at CMU, and then one I think is here for the last year graduate school, and unfortunately I cannot convince to focus on semiconductor. He decided to go to Google, So hopefully one day we'll get him more involved into the silicon side. But he took double E and took computer science. And so, he become very, very unique that he can have both hardware and software. But he was heavily recruited by Google. So he's delighted to see that. Uh, the other part in some of the audio, like long time ago, I invest in creative technology, the Sound Blaster. Some of you at the computer that you're familiar with that. It changed the whole machine sound to more the real life sound. There's a lot of other stuff that I invest in, but it's kind of fun to see some of this one become driving some of the real unique products. And so I'm continuing investing it. I mentioned earlier, lately I've been investing a lot in the biotech healthcare area. And there's a lot of new application from semiconductor. Like Berkeley Light, I like it a lot. And, it basically driving the next generation of drug discovery for some of the real problem like cancer, how do we treat cancer. And then, and also we have one real-time mass spectrometer called Autonaut. This is a company we just funded, actually started in Japan. And then the two professors involved in that, and eventually we got him to spin out and then to do that. And then the Berkeley Light is a spin out from Berkeley. Terilla, we can do 100 CPU, massively scalable. Actually, that come from a professor from MIT that I convinced him to spin it out, and then we able to do that. And so many of this investment I make is actually the idea come from the professor and student. And then they come out, and then I managed to get excited. And in fact, there's one company, Lion Semiconductor, down at the bottom in the power management that really addressing using the voltage regulator to drive 15-time error reduction for wearable become very important. Actually, it's a 5 PhD student, 3 from Berkeley and 2 from Harvard. And they decided to come together with 2 professors, and then the professor willing to put 100,000 each. That's a lot of money for professor. And then they like their students so much and support them. And I think you will be surprised, a lot of this innovation, even like if you look at Google and Amazon and Yahoo, the professor are putting a lot of money, and then they become very famous, and because actually it's done by the student. And then they back their student and support them, and then get VC guy like us to participate. And it's very fun to do that. So anyway, just give you a flavor, a lot more to do. And I wish I had 48 hours a day, try to do both things. And just give you an idea, and still a lot of money to be made in the semiconductor side. So you look at company A, that's a company actually, the name is Umbrella, very capital efficient, only 24 million raised, and then it reached 1.1 billion. And it's a fabulous opportunity. And then power management, I see this company actually is in China. And a couple of guys from US, they decided to start company. There's no VC want to back them. They came from Linear and then Monolithic Power. And then I backed them, and they decided to move in the R&D team in China. And then guess what? There's 650 million, all they so can be very capital efficient. And then the other one, I'm not quite sure which one is which one. The M company, I assume, is the mobile eyes, and it's almost 12 billion market cap, and basically doing the automotive, the collision avoidance that I talked about. And then I think there's another company, Nest, I think is the IoT, and then the other one is a GoPro. And so the last one is a GoPro. So in a way, you can still make a lot of money. And then GoPro, I put 10 million in. Right now market stand about almost 300 million in that. So a lot of money to be made. So I don't believe it's a sunset industry. It's more how to do it, and then have to be more capital efficient, more targeted, and then know how to do it. And if you can do smart engineering, you can steal a lot of money to be made. Of course, not the same as my friend making the WhatsApp, and from Sequoia, Jim is a good friend of mine, and but still a very decent return, and may not get the home run, but you can get a lot of double single, and you can still win the game like Giants and last night, so still can do that. Just a little bit highlight, since I came on board 6 years ago, we have been building up the cadence and, have been consistently able to generate a lot of system company software have been working with us, and we're very excited. And then since I came on board, also building up the IP, so make it easier for the designer to build the system on chip, and much quicker because we provide all the key IP for them, so they can come to market much faster. So in the way I kind of look at it, the main reason I jump into Cadence is basically try to help the designer in a much faster and quicker way to design chip, and more elegant and more time efficient way to do it, so that can hopefully contribute to the industry to grow even faster. And so that's very exciting. I think this chart would be very relevant to you. And this I check, the software and semiconductor still pretty high compensation for college. And in fact, right now, even at Cadence, we have a very active program to recruit the best student from the university. And in fact, I was attending because 2 years ago, I think my son was graduating, and then I attended the graduations for the CIT, and I found that there's a best PhD paper or award, and I immediately sent to my team, we should hire that guy. And then my team is so far said that we already hired, he already accepted our offer. I said, great, they're just delighted. So I think continue, I had to highlight, I don't know how many of you are in the software, and then software right now is about 3 times under hire. So there's a huge, the demand for software, and then especially if you have double E in software, there's a very big demand for that. So I think if you are in this space, you're in the right place. You don't have to worry about finding a job, and so should be pretty quick to get that. And then so far, if you look at the list, computer science, and then computer engineering, and pretty good in terms of high demand in terms of the requirement. And then in summary, I think I don't want to take too long a time, but I kind of quickly summarize a couple of key points. I think it's more important to entertain some of the questions that you may have, and then I'm happy to share with you why I'm so excited, and you're in the right place, and it's a big demand and for your talents. And then anything you want to learn more, we will be delighted to share with you the impact to the 7 trillion industry, and then more and more new application find for the semiconductor. So not necessarily just IT side. There's a lot of opportunity, and I'm heavily investing into this whole healthcare medical devices related. IoT also, I mean, all the killer app, the big killer app actually is healthcare related. And then how to communicate with your doctor, and then to your peer, and then to do the right thing, and then more preventive than wait until the problem comes. So with that, I will just open up for any question that you may have.
Okay. Thank you very much for the nice talk. Any questions?
Tim Bob have a question.
So let me ask a simple question. Way back when I was doing hardware design, it was soldering irons and wire wrap guns and TTL data books. I think this one's for things. We haven't gotten to that same level of simple composability with IP blocks. Can you comment on what would the industry benefit from that same level of composability? You mentioned IP blocks and libraries and the value from that. Maybe you can say a few more words about how do we get back to the world of the TTL data book?
Yeah, good questions. I'll try to answer that. I think clearly 3 years ago, when my customer asking me, Lip-Bu, what is your IP strategy? Actually, we have none, zero. But very quickly, we acquire quite a few key company, like Tensilica we acquire, and Denali for memory module IP we acquire. And so right now we're number 4 largest now. And of course, number 1 and number 3, we don't compete. That is ARM and Imagination. But the IP, the trend become almost like 30 years of EDA. Used to be IBM have all the EDA, and then they starting to decide that we should outsource it out. That's why we have Synopsys, Mentor, and Cadence. Same thing happening with IP now. It becomes so expensive to keep. And then some of them are industry standard, and it's very hard to keep up to date on all the USB 2.0, 3.0, 4.0 coming. And so they decided to outsource it out. And that's why Synopsys and Cadence become very quickly ramping up the IP business. And then today we are almost more than 10% of our revenue come from IP now, and it's still growing, the fastest growing area. Back to your question that, whether can make it easier and simplify. I wish that would be the real case, but unfortunately there's so many protocol, not, some of the new development, they all want to have some different, tweak, and then they are all fighting religiously to protect their IP standard. And then so in a way, for us, we try to provide, all the standard requirements, so that meet the customer, requirement to make it easier for customer. But one day the customer will become so easy to just pick up a few and put it together and then meet all the environment. It will take a while. And so because of complexity and also different application need different standard, and system level approach become very important. And so it really kind of driving some of the new standard because it's a new area and always has some differentiation. And eventually they become one dominant standard that was much easier. And so I think this is going to be continue evolving, and there's no shortcut to it. And in some ways, good for us. So we can have more business.
Any questions from Pittsburgh, maybe? Yes, go ahead, please. Could you please keep pressing on the button, maybe, while asking the question? Yeah, thanks.
Good question. A couple of reasons. One, you are correct. They don't see the return because of the way they're doing it. And the normal way in US in the investing in silicon is if they see some new technology, they are very good at it. They put money with them. And then without talking to the customer, they pour a lot of money into it. When they solve the problem, they're starting to engage a customer. And then it takes 6 to 9 months. And when you build out a team, almost 1.5 million burn rate, and then Bob will know very well, every time you delay, it's just killing the return. And so that's why a lot of VC, have a traditional formula is you have to invest 100 million to see some return. And that, and then hopefully one day it will go public at 1 billion or 2, or Broadcom or Qualcomm will buy it for 1 or 2 billion with very little revenue. Those days are gone. And so you really have to show the technology and also show the customer. That's why I mentioned earlier, every investment I make in the semiconductor side, I want to look for capital efficient, very targeted, who is a customer, who are the application you want to go after, and then have the right team. Actually, to be candid with you, because so many investors are not investing, so the quality actually much better. And so a lot of more experienced executive come out and then more elegant way to address a problem. And people pay attention to save money, do the right things. So in a way, I think the return starting to show now. And then hopefully one day the VC guys starting to be interested in that. And so I think you just have to look at the global point of view. Like me, a lot of time, company we invest in, the architecture design is actually in US. But the actual coding and circuit in our design is in India or Taiwan or China or Korea. so that you have that kind of 24 hours turnaround. And then the other thing can be much more capital efficient and to drive some of this innovation. And so I think all in all, I think the main reason the return is not as attractive as I call it much harder to invest making return on the semi side than the WhatsApp. WhatsApp is the capital very efficient, and then very soon you will know. Frankly speaking, WhatsApp had no revenue, but people willing to pay 19 billion for it, and so I think that environment has changed, and you just have to find a different formula.
Okay, any other questions?
Sure. Yeah, good question. I think most of the successful fabless company, I think they are spending close to 20+% on R&D. If you look at Qualcomm and the others. And then on the Cadence side, because I'm heavily focused on innovations, because as you look out, being a VC, I look out, there's not many startup in IP or EDA. And so in the future pipeline, I don't have a lot of company to acquire. So I decided to change, and I also want to take some leadership in some of the product group that today I'm number 2 or number 3, and I want to be number 1. So we basically drive a lot of R&D, not quite 40%, I think it's about 34, 35% in R&D. And so we just have to continue investing because of, I come from behind at a couple area. I'm not the number 1 yet. And then our goal is to be number 1. So we are driving a lot of more R&D investment. And the other part, because our margin is very good because we are a software company, our margin in the 80+%. So I can afford to put some R&D, 35%. And I still enjoy, 25, 26% operating margin. And so that is something unique for Cadence. And also the IP business, if you do it right, it's very profitable. And then like Tensilica, we can charge royalty per every unit people's customer ship. And that can be very nice business, just like ARM have. And then so ARM, as you can see, their multiple is almost 15 times revenue. And because of that loyalty stream that coming in. So I'm kind of working towards that. So hopefully there's some really key star IP block that I have that can worth a lot and in terms of loyalty payment.
Okay, I think we can wrap it up. Let's give Lip-Bu a big applause. Thank you so much for.
Thank you.